So nested arrays are also called multi-dimensional arrays, which just give it that whole science fiction feel and let you feel like you're walking down, you're suddenly a captain of a starship and you're going through a wormhole and you got to go through multi-dimensional arrays. And so the reason why they're called multi-dimensional arrays is each level of the array is considered to be a dimension of an array. So a two-dimensional array would be how many arrays?
Two.
Two. A three-dimensional array would be three. And a four-dimensional array would be four, right? So that makes sense. But for our purposes here, we're gonna refer to it both. We'll go back and forth between nested arrays and multi-dimensional arrays. So why do you think we might want to use a multi-dimensional array? Why would they be helpful?
For organization.
Like, what do you mean by that?
So you can have an array within an array within an array.
Right. Yeah. But why would that be helpful?
Well, like, I'm just thinking if you have different categories, like you have like a person, and then you have like their description, like their height, their age, and then you go down even further into more information.
Yeah, that's totally right. In fact, here in the lesson, they provide you an example of a multidimensional array. So here's an example of what it might look like when you're accessing the Google Maps API. And we'll get in just a second what an API is and what Google Maps API might be. But here might be an example of what you might get back. So you might get back a location array, right, which has a top-level array that contains two arrays, just for this example. One would be the Flatiron school with its GPS coordinates, and the other one would be Disney World, because the two favorite places in the world are Flatiron and Disney World. And so you have two arrays within the top-level array, each array containing the name of the place and its coordinates. And then and each one of those is its own individual array. So just like you said, the reason why you might want to have multidimensional arrays is for organizational purposes, right? And here you're able to clearly organize your content in a way which makes a lot of sense. Taking one step back, when I said API, did you know what I meant by that?
Yeah, it's like a huge organization of data. I don't know exactly what it stands for, but like I've looked at an API for Star Wars.
And then Star Wars API, that sounds like fun.
Yeah, Karena's been doing something with that. It's pretty cool.
Let's take a look.
And when I get to my project, I want to use the API, though.
Yes, it does make sense. So APIs, an API stands for an application programming interface. It's a set of subroutine definitions, protocols, and tools for building application software. In general terms, it is a set of clearly defined methods of communication between various software components. A good API makes it easier to develop a computer program by providing all the building blocks, which are then put together by the programmer. An API may be for a web-based system, operating system, database system, computer hardware, or software library. So an API is essentially an interface. It's in what form it takes is actually, it's a bit agnostic. It can be used for databases. It can be used for desktop software. It can be used for web applications. It basically provides you with all the tools for building the software. So what then is a web API? Because that's what we're most often thinking about. A web API is essentially an access point for people to access, for external resources to access the resources that you have within your web application, within your database, within your web application. So what might be an example of a web API? You just mentioned one.
Well, the Star Wars
one. Right. So what happens when you go to the Star Wars API? What do you get from it?
You can look up every planet, every character. You can look up every Ewok. It's pretty cool.
Every Ewok, every single one of them. Yeah. So that's a great example of a web API. Google provides tons of APIs for developers. Facebook provides APIs. Twitter provides APIs. Almost every single modern major web service provides APIs. Access points for developers. And the reason is because they want you to incorporate their services into into your programming, because it only benefits them, because the more access that you're providing users into their service helps funnel more people into their service. And the more that you're dependent on the data they provide, the more valuable the service they're providing, right? And so, like, for example, in the Google ecosystem, you might have access points, you might have APIs around Google Maps, Google Search, Google Contacts, Google Calendar, etc. And within Facebook, you might have APIs that allow you to read people's timelines, to edit timelines, to add to a timeline, API around Facebook events or Facebook groups. In Twitter, you would have APIs that allow you to create Twitter bots, right, that allow you to post to Twitter, to search through Twitter, to respond to tweets, etc. And so within the universe of APIs, there can be APIs that are totally open, totally public APIs, where you just have to know the address and access the data. And then more often than not, with larger services especially, the APIs might be locked and require credentials. And you can imagine why credentials would be an important aspect to the building of the API architecture, because the services might want to track who's using the API, what kind of data is being accessed, how often it's being accessed. They might want to limit the amount of data that you're accessing on a weekly or monthly basis, and they can only do that if they track you through some credentialing system, right? So, for example, this is a website that I use often in my own sort of like open source work. And this is an API example from this website. So when I go to this website and I access their API, like in my React app that I'm building around this, so the way I would do that in my code would be, I would create it, and this is not for now, but I would create it as an action on my API. And then so I'm going to fetch from this API this website, and I'm creating this as a variable that I can put in depending what text I want to fetch, right? That makes sense. So I don't have to create 30 different ones for every type of text I want to fetch, right?
Right.
And when I do that, what I get back is this, which is a lot of data, right?
Yeah, it looks like really interesting Jewish data.
It's really interesting Jewish. It just happens to be a personal interest of mine, right? So I'm getting back all this data, and I'm getting it back in what kind of format?
Nested arrays, maybe.
Well, yes, but you know the format I'm getting it in?
I don't know.
It's called JSON. This is
JSON. Yeah, I know JSON now that you say it.
So the reason why we're talking about this is because one of the most frequent places you'll find nested arrays is when you're accessing API data from an API. And it's just helpful to take like a 5-minute detour and sort of walk down that rabbit hole of what APIs are. So you get back JSON, and JSON is JavaScript object notation. It's become the universal standard for how you send data to web applications or applications in general on the internet, and how you receive data back. And so if I would open up like my Chrome inspector, the data is automatically saved into the window .json. So I could call that, and look at that. Look how many layers are there. And these are all, what are all these? What are those two brackets representing?
An array.
An array, and there's hashes within the array, right? With key value pairs, tons of arrays. And here's like three different arrays, each with its own hash set of key values. So this example here doesn't give us any nested arrays, but it does show you that what you're basically getting back from basically every single API you're going to reference is arrays. And often, especially if the data gets super complicated, you're going to get back layered arrays or multi-dimensional arrays. 2-dimensional, 3-dimensional. More often than not, it's never going to go past 4-dimensional, because it's best practice not to traverse past a 4-dimensional array. Anything beyond 4 dimensions just gets a little too convoluted. And if you really have that much data, you might want to think about A, how you're structuring your data, or B, perhaps you need to break out your data a little more, so it's not so many layers, because it just gets a little too, makes the head explode. Yeah, too much data there. I see something in the chat box. Be sure to mute. Oh, okay, that's not for me. I'm not going to mute myself. Okay, so let's continue in this lesson. So let's actually build a nested.
Hey, Sam, can you mute yourself so we can hear Ben good?
Oh, sorry about that.
No problem.
So let's actually start building a nested array and play with it. So first of all, how will we build a one-dimensional array, also known as your average simple one-layer array? How do we build that?
You need some brackets.
A literal object constructor, right? We're just gonna let's put it into a variable so we can play with it later. So let's call it one dimension, and right. So now one dimension is a one layer array, right? Simple. So if I would do this with one dimension, what would I get back?
You would get back the first part of your array. So you get back number 1.
I would get back 1, right? Okay, so let's now build a nested array. So we're going to break it down into multiple lines just to make it easier to read. So let's do
I have a quick question. Is it common practice to space it like that on each line, or would it in normal code just be straight across the screen?
So it really depends. If you're only doing, let's say, a 2-dimensional array, you might, so like if you wanted to do something like, you could do that. It's still pretty easy to read, right? You can kind of get a sense of that there's 2 brackets, you're opening with 2, and then you're closing with 2, and in between there's 2 arrays. It kind of, you can read it. The only reason you want to space it out into multiple lines is for readability. It's not for the actual functioning of the program or for the code to compile. It doesn't change anything, whether it's on 1 line or 2 lines or 10 lines. It's just to make it more readable for you and for other developers.
Right. Okay.
Yeah, that's the only reason. So like when you start getting into like, you know, yeah, I don't even know if that's proper syntax there. I'm just being ridiculous for the point of absurdity to make the point that like when you start getting into, you know, really complex array formulations, you might want to break that down into multiple lines because it's just going to get really complex. So here we have created, now we have 2 arrays, 2 variables, but holding 2 different array formations here. One is one dimension holding a one-dimensional array, and the other one is a nested array holding 3 arrays within a top-level array, right? So if we were to call nested array 0, what do you think we would get back?
You're going to get the whole first array.
How do you know that?
Because I love arrays.
That is awesome. You got the answer. That is right. Because if we do that, we're going to get back the entire first array. As opposed to on line 3 in our IRB, what did we get back when we called 0 on one dimension? We just got back the first value within the first item within the array, right? We didn't get back the entire array. So why do you think in nested array, when we call 0, we get back not the first item within the first array, but we get back the entire array? Any thoughts on that? Why the distinction there?
Because in the nested array with like arrays in it, each of those arrays inside of it actually is an index.
That is exactly right. That is 100% correct. Each of the arrays within the nested array is in itself an index number. It's located through an index number. And so, whereas on line 3, index number 0 is referencing the first item in the array because there is only one array within our one-dimension variable. In line 4 through line 8, when we're creating our nested array, each array 5, 6, and 7 occupies a different index location number within our top level array. our top level array being defined on line 4 and being closed on line 8. So when we call nested array 0, what we're actually saying is find me the item that is located on index number 0, which happens to be, in this case, an entire array. In case number, on line number 3, in that case, it happened to be the first item in the only array that's present in that variable. So if that makes sense, let's do this. What are we going to get back now?
4.
You're right. Because now we're saying find me the item in the variable nested array that's located on index number 0, and find me the thing that's located on index number 0 in index number 0. So find me first index number 0, right? The first one. And then find index number 0 in that index location. So what we're doing is we're drilling down, right? Does that make sense?
Can you do another one?
Yeah.
Like that?
So do you think this would work?
No, it wouldn't.
Right, so let's see. We get 0. Why would we get 0?
Because it does not exist.
It's not there. There's nothing. There's no data there. But what if we did something like what do you think we're going to get back here? What number are we going to get back in our nested array? 4, 5, 6,
11.
9, 10, 11, or 12?
I think 11.
You think 11? Let's see.
I think 8.
Oh.
1, 2.
Woo!
This is.
How did that work?
So how did that work? So let's break it down. So here's our top level array, right? On line 4, when we open it with a bracket, that's our top level array. We're closing it on line 8, right? Here on line 5 is index location 0 in our top level array. Line 6 is index location 1. Line 7 is index location 2. 0, 1, 2. 5 is line 5 is index 0, 0. Line 5 is index location 0. Line 6 is index location 1. And line 7 is index number location 2. So when we say nested array location, index location 2, we are referring to line 7 in this nested array formation. And then we say I want the index location 1 within index location 2. So now we go into the array, and number 10 is on index location 0, and number 1 is index location 1 is the value 11. Does that make sense?
Yeah, that's awesome.
That's cool, right? And now we can even make it simpler for ourselves. So like this can get hard to remember, right? So we can do something like this, like so now we've assigned the value of the second array within our nested array to a new variable called second array. And we can manipulate that line as like that, or like that, or like that, or like that, or like that, right? All the different methods we have to manipulate array data, we can use that on our second array variable. So we could do that, and we could put in and then if we call the entire nested array, do you think that's going to be in there?
Yeah, you shuffled it in.
You are right. Exactly. So now we got 4, 5, 6, 7, 8, 9. What? I'm not a number. 10, 11, 12.
That's funny.
And the point of putting in that string is to remind ourselves that arrays don't all have to be consistent in the data types that are within the array. Right? Arrays can have heterogeneous data types. It does not have to be homogeneous. That arrays, if you want to add an H in front of it, arrays can be consisting of multiple types of data. So here we have arrays with a bunch of integers. We also can throw in a string, right? And so second array we can keep on playing with second array. So we could, you know, dot pop and popped off what I'm not a number, right? So now if we look back in nested array, it's gone again, right? Now, how do you think we might want to iterate over a nested array?
Could do select.
What do you mean by that? Tell me the syntax. Let's walk through it.
Okay, so which one do you want to do? So nested array dot select, and then pick something to select. What do you want to select?
Would that work?
Maybe.
Nope. Should we look up dot select?
Yeah, look up select. I love select.
Select returns an array containing all elements of a numerable for which the given block returns a true value. So if no block is given, a numerator is returned instead. So select would be we take, oh, that's really interesting, right? So we would take our array and we would call select and we would give it a condition by which we want to return the data within it. So this is a great way to make a conditional statement. So we might want to do something like
get all the even numbers.
Exactly. So let's actually follow the syntax there. So nested array select num
Doesn't look like it worked.
It didn't look like it worked. Oh, but what if we did there we go.
Okay.
So why do you think it didn't work for nested array, but it worked for second array? That's actually a good point. Why is it only working for one of those?
Will select not work on multiple, like, dimensional arrays?
Exactly. Select will not work on a nested array. We can't call number even. We can't go through select on multiple levels of arrays. But what we could do is maybe what we could do is something like this. Yeah, okay. Let's do it like that number and then
Can you do odd numbers this time?
yeah. There we go.
Oh.
What did we do here? And truthfully, I could have broken that into multiple lines to make it a little easier to read, but what did we do here? Does it make sense?
You used map. But go ahead, Emmy.
Oh yeah, I was gonna say that it looks like you used map to iterate over all of the numbers, both in the first level and the second level.
Yep. So I use map to first create an iterative function to go through every layer of the array, right? And we could use another iterator too, but we're just using map here as an example to go through all the levels of the array. And I've defined as it iterates through, we assign wherever it's at that moment of iteration to the variable num, right, num. And then instead of putting num.even or num.odd, I actually called another iterator, num.select. We're now using select within the map function. And we're asking that to see what numbers are odd as it goes through it. So whereas on line number 21 of IRB, right here, where we could not do even, we cannot call a function on our nested array as it stood by itself. On line number 23, once we're iterating through each array, within the nested array, we're more than welcome to call something like dot select or another iterator within the iterator. Does that make sense?
Yeah, I like math. It's cool.
Right, right. So let's actually take a look at the lesson here because it does talk about that. So let's just take a look at this together. To access data from and add data to a nested array, we use the same methods we've been using to deal with one-dimensional arrays. So here's a one-dimensional array, students, right? And then here's a nested array called nested students. And nested student 0, as we now have learned, returns us the entire first level of the nested array, right? Which would, in this case, we might grade 10 A average. And then if we, right, okay, so let's continue down. We know how to do all of this. We're experts on this now. Good job, guys. So here, let's read this. What if we want to add data to every array that is nested within the parent array? It would be very tedious if we had to calculate the length of the array and then one by one modify each individual child array using bracket notation and the shovel method. When we're dealing with a one-dimensional array and we want to do something to every element, we iterate using methods like each and collect. If, for example, we wanted to put out every member of the student array, we could do something like this, right? Students.each do student put student, right? That's very simple. We've probably done that tons of times at this point. In order to manipulate or operate on each element of a nested array, we must first dig down into that level of the array. So that's exactly what we did when we did this on line 23. We've dug down, right? Does that make sense? We've dug down into the actual nested arrays. So in order to manipulate or operate each element of a nested array, we must first dig down to that level. So here's our nested array, which has 3 arrays within a top level array. And nested students.each do student array. Inspect returns a human readable representation of the array. Put student array dot inspect. So let's do that for our own, right? So nested array dot dot each do single array. Put single array dot inspect. You see what it returned to us? It returned to us our 3 arrays within our nested array. And it returned them one at a time. 4, 5, 6, 7, 8, 9, 10, 11, 12. So what does single array hold? Each time we iterate through nested array and we assign it to the value of single array, what's the value of single array?
It's each index.
It's each array and on its own. So at any given moment when we are iterating, at that moment of iteration, and we're looking at a value, that value for single array will be an entire array. Will be one of the nested arrays in its entirety within nested array. Is that clear?
Yes.
It is, yeah.
If it's not, let me know because we can spend a little more time on it. This stuff
makes sense.
Okay, cool. So that means that at any given moment, single array equals one of the arrays within our nested array. Instead of putting something like a put statement on line 25, we could put another statement or another function to do something with that single array, right? Which is exactly what we did on line 23. Because here, nestedArray.map, we assign that to a value of num. Num at any given moment equals an entire array, right, of one of our 3 arrays, the nested array. And then we're saying that each time you iterate over the entire array within one of the entire arrays within our nested multidimensional array, I want you to call select on it and return me the numbers that are odd.
Yeah, and it's cool because it even grouped them within the arrays. If you see, 5 was the only odd in the first array, and then 7 and 9 were both odd in the second array.
That's beautiful. It makes it so easy to actually understand what you're getting back too.
It's cool.
Yeah, it's really cool.
So if there were people, if each array was a person and those numbers were assigned to them, you would know, like if the second array was Bill, those numbers belong to Bill, kind of.
That's right. No, you're totally right.
It's cool.
So let's do this. Let's see what happens with our example. So nested array, let's just follow the example there. Yep, okay. Nested array.each.do, let's call it each array, each array.each.do values. See what we get back? What's different from what we got back here than what we got back just right before?
The first one you were getting just the top level of it, which is each array, and then the second one you actually went down another level and got each index of each array.
Exactly. So whereas in the first time we got back the entire array as an entity, in this example we drilled down further and we got back not the arrays, we got back the values within the arrays, or we got back that data within the arrays. We could have used the word data to hold it, or items. We got back the items, the data, the values within each array, and we got them all back, right? It spat all of them out, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And then as opposed to giving us back them in array form, which is exactly what they get back in their example here as well. So when might you want to use a multidimensional array? So we kind of talked about this a little bit in the beginning, but when you're storing data that has a strong relationship to each other, and that relationship specifically being one around a hierarchical structure, it makes a lot of sense to store it in a multidimensional format. So for example here, this is a great example the lesson provides, a music library. So a music library will have an artist will have an album or more than one album, and within the album will be a collection of songs. So the top level might be the artist, the second layer might be the album, and then the layer within the album might be the songs that are within that album. So that's a really good example of when you might want to use a multi-dimensional array to store data, when it really makes sense. When you don't want to use it is when it doesn't make sense. So like, you know, just for the, like this example here, it might not make a lot of sense in a real world application to break down, you know, sequential lists of numbers into 3 different arrays. But here it makes a lot of sense. And so you might create your music library to look something like this, right? And someone asked a question earlier about like whether you put it all in one line or not. So this is all in one line. Do you see how like it's readable, but it could be a little more readable if it's broken down? I forgot who asked that.
That was me, and yeah, it's kind of harder to read that way.
It's kind of harder to read that, right? Exactly. And so like here's it broken down, and they even say here, it can be difficult to read through the data structure in a way that makes sense. A useful tactic is to format the array such that each nested level is placed on its own line. This can make a complex structures much easier to read. So broken down, it becomes, as opposed to this, yes, it's taking up more space, but it's just a much simpler way to understand it. So you got your top level array, then you have your second layer array, and within your second layer, you're creating 2 arrays, right? A third layer for the name of the album, and then the songs within that one. Then you close that one on its own line, and then you close the album, and then you open another album, and then within the album you create another array of songs, and you close that album, and then you close the artist, right? So 1, 2, 3, closing 2, and then another 2, 3, closing 2, closing 1. And then we open another one here, and we do the exact same thing. And then we make sure we close all of the open ones we've left. So if we would do something like, let's just copy this for a minute. There's our music library. And then if we would do that, and then copy this, now this is cool because what's happening here? What's happening in lines 9 through 12 of this code? Well, what's happening? Yeah,
It's saying if the artist element or name is not equals to what is in the array, it's a reprompt for the artist and its elements one more time.
Yeah, that's really close. That's a great read of it. It's saying something a little different, but that's actually a really good attempt at reading it. What it's saying is that if what you're getting back on this layer, if what we're getting back on this layer, so remember this layer will return to us all the arrays, right? Because that's the first layer. And then we want to iterate through that layer of arrays. So this is the second layer. And if in the second layer, what we get back in that moment is not an array, if it's not an array, what is it?
An element?
It's an element, it's a string, right? If what we're getting back is not an array, in this case it would be a string, then what we want to do with what we're getting back is we want to actually put it out. We want to print it. And what we want to print is this string, artist with its name. Because if what we're getting iterating through that moment is not an array, then it's going to be a string and it's going to be the name of the artist. So we want to put out the name of the artist. But if what we're iterating over is an array, then we want to drill down one more layer. Because what we're going to drill down into the next, what we will be drilling down into is the next layer, which will be the albums and the album arrays. And then if what we're looking at there in that moment is not an array, then what will it be? It'll be the album name, which is a string. Then so we're going to put that out, album with its name. But if what we're looking at is not a string, it'll be in another array. So we'll want to drill down another layer. And we drill down another layer, we're going to get to the song arrays. And so that's where we're going to be. And then in the song arrays, there are no more arrays. We know that because we structure the data, right? We know what our data is. So there, we're just going to put out the song. We don't need to create a conditional. So let's do that. So where were we in copying? Artist array of each. So if
I love when you just do this, Ben. This is wonderful.
You're
like, let me just take the example and stick it in the terminal. We're good.
Well, let's see what happens, right?
I love it. Yeah.
So what do you think we're going to get back? So before we even press enter, let's take a look at this for a second. So here's our this is our whole music library variable, right? Consisting of a bunch of nested arrays. And so where we're saying on the top level on line 50 is I want to go through this variable and I want you to iterate through it, and I'm going to call it artist array. Why am I calling it artist array? Because what's in the second layer? What's in the first arrays within the top level array? Adele, Beyonce, right? Does that make sense? What are those? What is Adele and Beyonce?
They're the artists.
They're artists, right? and they're awesome artists. And so we're calling it an artist array because it happens to contain the data of names of artists, right? And so I want you to go through the artist array. Now, what is inside the artist array? What is inside it?
The albums.
The albums. And what kind of data type are the albums? What kind of data structure? I apologize. Data structure.
It's an
array.
Yeah.
Exactly. So I want you to go through the artist, and if what is inside of it is not an array, is there something inside the artist that's not an array?
There's an array in the array, but
yes, but what's first here?
Oh, the string?
Yes, 1921-4 Beyonce, right? So those are not arrays, those are strings. So if the artist element class is not an array, if what I'm looking at right now is not an array, then I want you to, right here, before we get there. Adele, Beyonce, right? Then I want you to put out her name. Artist Adele, artist Beyonce. But if it is an array, then what I want you to do is I want you to iterate over that one. And so what's the next layer? 19, 21, 4, Beyonce, right? And so I want you to iterate over that, and I want you to make the same conditional as well there and put out the album name if it's a string. If it's another array, I want you to iterate over that, which would give you Daydreamer, Rolling in the Deep, 1+1, Haunted. And there we have no more arrays. We only have strings, so I don't need to worry about the conditional, so I just put out song with the song name, right? Sound good? Let's see what happens. Look what we get back. Artist Adele, album 19, song Daydreamer, song Best for Last, album 21, song Rolling in the Deep, song Rumor Has It, artist Beyonce, album 4, song 1+1, song Countdown, album Beyonce, song Haunted, song Pretty Hurts. Cool, right?
Super cool.
That is super cool. That's a great way to return your data. And obviously we have so many fun end statements here we get to look at. A whole like tree of ends. It's a beautiful line of ends. Because we have to always make sure we close everything out, right? Every if needs an end. Every opening of a block needs an end. And so we get this beautiful looking code from lines 50 to line 66. Any last questions on our nested arrays? Because you guys are now nested array